Hello everyone, my name is Hari Krishna. I am from CSE department. Today I am here to say about the traversal of binary search tree. In this PPT we are going to learn about what is tree, what is binary tree, what is binary search tree, and operations on binary search tree, traversal techniques on binary search tree, algorithms for traversal techniques, and the examples for this. Firstly, learn about what is tree. A tree is a data structure. It is defined as collection of objects or entities known as nodes that are linked together to represent or simulate hierarchy. A tree data structure is a nonlinear data structure because it does not store in sequential manner. It is a hierarchical structure as the elements in a tree are arranged in multiple levels. In tree data structure, the topmost node is root node. Each node contains some data and the data can be of any type. Each node contains some data and the link or reference of other nodes that are called as children. And let's say example of a tree. Here it is a tree and A is root node as it is the topmost node and C, D, E are the child nodes for B. Here C, D, E, G, H, K, L, P, Q and N are the last nodes called as leaf nodes. Let's see what is a binary tree. The binary tree means that the node can have a maximum of 2 children. Here, binary name itself says that 2. You know that binary means 2. Therefore, each node can have either 0, 1 or 2 children. In the example, we can see 1 is the root node and it has 2 children 2, 3. Here 3 does not have any children but 2 has 5, 6. We can clearly see that it has 2 nodes or 0 nodes or 1 node. Next, what is binary search tree? A binary search tree follows some order to arrange the elements. In a binary search tree, the value of left node must be smaller than the parent node and the value of the right node must be greater than the parent node. This rule is applied recursively to the left and right subtrees of the root. Here 40 is the root node. It has 2 children 30, 50. Here 30 is less than 40, so it is in the left part of the 40 and 50 is greater than 40. So it is right side of the 40 and 30 has two children 25, 35. Clearly 25 is less than 30, so it is in the left part of the root node and 35 is greater than 30, so it is in the right side of the root. Same for 50. Here the root binary search tree property holds at every level. Now we see operations on binary search tree. There are various operations performed on binary search tree. They are traverse, search, insert and delete. In this particular PPT we are going to see about the traverse of binary search tree. Traverse of binary search tree. Traversing means accessing each element of the data structure. In this we are using tree data structure, so accessing each element of the tree data structure at least once is called traversing. Traversing is of 3 types: in-order traversal, pre-order traversal and post-order traversal. Let's see the algorithms of this traversal. In-order traversal. Initially we have to traverse the left subtree, now visit the root node and then traverse the right subtree. Pre-order traversal. First visit the root node, then visit the left subtree, at last visit the right subtree. Now post-order traversal. First visit the left subtree, then visit the right subtree, at last visit the root node. Now we will see about the example. For in-order traversal, let us consider the following binary search tree. For in-order traversal, we will follow this rule: left, root and right. In in-order traversal, first traverse left subtree. Here this is left subtree and remaining this part is right subtree. Now we have to traverse the left subtree. in the first node in the left subtree is 2. 2 here 2 acts as the root node, and this is the left subtree of the 2 and right subtree of the 2. We have to apply the same traversal for this root node also. Here in the left part we have -4. It does not have any child nodes, so we have to add this -4 to the inner traversal. -4, and we have to go to the root. Here 2 is the root node, so 2, and right part of this is 3. We have to add this 3 to the inner traversal. Next, we have completed the left subtree of 5. So next we have to go to the root part. Here 5 is the root node, so add this 5 to the inner traversal. As we completed left subtree, now we have to go to the right part of the tree. While traversing right subtree, -17 is the first node. 17 is the first node and it acts as the root node. For this 17, left subtree and right subtree exists. In the left part, it has only one child node, 9, and it does not have any child nodes. So 9 has to be added to the inner traversal. Next, after completing the left subtree, we have to go to the root node. Here root node is 17 and 17 is added. Next, 21 is right node of the 17 and it has two children, 21 19 25. So 21 acts as the root node. Next we have to traverse left of the root node 21, and in the left we has 19. Add 19 to the inner traversal, and next coming to root node 21 is added to the inner traversal, and next one is 25. Right part of the root node 21. 25 is added to the inner traversal. We have traversed each node of the binary search tree once and obtained the inner traversal as follows. Here if we observe clearly, it is in ascending order, so we can understand that if we traverse a binary search tree in order fashion, then we will get ascending order. Let us see pre-order traversal. For the pre-order traversal, we will follow this rule: root node, left and right subtree. Because in the pre-order traversal, first we have to visit the root node and next traverse the left subtree and then traverse the right subtree. We will consider the same example for pre-order traversal also. Here 5 is the root node and this is the left subtree and this is the right, and this is the right subtree. Here first we have to visit root node, so first 5 is added to the pre-order traversal. Next we have to traverse left. In the left subtree, the first node is 2 and it has two children, -4, 3. So we have to add the root node 2 to the pre-order traversal and traverse left, that is 4. So visiting -4, we add -4 to the pre-order traversal, and then next visit right part. In the right part we have 3 and 3 is added to the pre-order traversal. We have completed root and the left subtree. Now we have to visit right subtree of the root node 5. In the right subtree, the first node is 17 and it has two child nodes, 9, 21. So we have to add root node, that is 17, to the pre-order traversal and then next to traverse left subtree. In the left part we have 9. So there is no child nodes for 9. So I have to add 9 to the pre-order traversal. Next is right subtree. In the right subtree there is 21 and it has two child nodes, 19, 25. First add the root node to the pre-order traversal. So 21 is added to the pre-order traversal. Next visit left subtree. In the left part we have 19. 19 is added to the pre-order traversal, and the next node 25 is also added to the pre-order traversal. So we have visited all the nodes and we obtained the pre-order traversal as follows. Now let us see post-order traversal. In the post-order traversal will follow this rule, that is left, right and root, and we'll consider the same example. Here 5 is the root node, and this is the left subtree, and this is the right subtree. As per the rule, we have to visit the left subtree first. So visiting left subtree, there is 2 and it has 2 children, minus 4 comma 3. So we have to visit here left part, which is minus 4. So minus 4 is added to the post order traversal. Next right in the right subtree, right node, we have 3. So 3 is added to the post order traversal. Next we have to traverse root node. Here 2 is the root node and 2 is added to the post order traversal. We have completed the left part. Now we have to visit the right subtree. In the right subtree we have 17 as the root node and it has 2 children, 9 comma 21. In the left part we have 9, so it does not has any children, so 9 is added to the post order traversal. In the right part we has 21 and it has 2 children, 19 comma 25. In the left part there is 19, so 19 is added to the post order traversal, and right part 25 is also added to the post order traversal. Next visit the root node 21. 21 is added to the post order traversal. Next the root node 17 is also added to the post order traversal. In this way we have completed left subtree and right subtree. Now visit the root node 5. 5 is also added to the post order traversal. We have seen clearly the tree traversal techniques for the same binary search tree. Now let us see another example. For this example, we will consider the following tree as example. So here, in ordered fashion, left, root and right. If we follow this principle and apply this to the given example, we will get the following as in order traversal. And for pre-order, we will follow root, left and right. If we apply that principle, we will get this as the pre-order traversal. And next for post-order traversal, if we apply left, right and root principle, we will get this as the post-order traversal. So we have learned clearly about in-order traversal, pre-order traversal and post-order traversal on a binary search tree. Thank you.